Yeah, thank you very much. And thank you very much for inviting me to giving this talk here. So I like to give you some insights about the topic W3C Web of Things and how they are related to OPC and what you can do with it in the world of OPC. So this will be my focus in this talk. And yeah, and I want to give you some good takeaways that you have a good understanding what Web of Things is about, and yeah, and potential also maybe attracting to you to use also Web of Things, especially in combination with OPC. Yeah, I know Web of Things very well. I'm already working since, I would say, 8 years in this standardization in the Web of Things, and I'm also currently the Web of Things co-chair. So to give you also here this kind of background. And Stefan already mentioned we had already this similar talk in or at the Hanover Fair few weeks ago, and this was a joint talk together with Erich Barnstedt from Microsoft and also Felix, a colleague of mine. And there we had also this component ChatGPT in there. And this will be not included in this talk. However, I can really recommend to join Erich's talk tomorrow. He will then give more insight how ChatGPT can be used in the combination with Web of Things and OPC. And yeah, so you should definitely have this also on your agenda for the tomorrow's presentation. Right, and now I'd like to start a little bit to explain you what is actually the web. Yeah, and I think everyone who is listening to this talk here use the web in the daily life and of course also in your daily business. Yeah, you're doing web search and you're booking tickets, or you're doing a lot of stuff in the internet, and I would like to explain you what is the actually very cool thing of the web. And I always love to show this nice booking page here, where you're able to book your travel or book your specific hotel. And if you go to such kind of web page, then you'll find a lot of information and use service in the background, which are typical not owned by this website provider. Yeah, so for example, you see some location information that are typical coming from Google Maps, or you see some recommendation or comments from TripAdvisor, or you have also the opportunity to use social services here like Facebook, and you're also able to see what is the weather condition in this area, and all this different service coming from different stakeholders. However, they're providing their service, their web service in that way that it's very easy to combine, to orchestrate the service to a new business, yeah, so that you can create new content or combine the content. And yeah, and then you can provide something like that. Yeah, you offer a nice trip, a nice hotel here. And if you're happy with that, then you can going to pay with it. And as you know, there's some service out there that's kind of called PayPal, where you can simply pay your travel. And this is very impressive. That works very well. And one of the reasons is there are web standards behind of that. Yeah, in the background, there are web standards specified, like specified by the W3C, for example, and they have a lot of building blocks which relying on this kind of nice handling of combining service to each other. Yeah. Now I like to move to our IoT world, and here I like to challenge the question, or to say the statement: this is not very easy to combine different services from different ecosystem, IoT ecosystem to each other. For example, to create application and challenges of our today's world situation, like how to optimize the energy consumption, or to increase the sustainability aspect, and so on. And this is, to be honest, not a very easy task to combine different scenarios, IoT devices, and IoT ecosystem. And what are the reasons for this? So the reasons are that typical different stakeholders have different backgrounds of technologies, like protocols and data models behind of that. Yeah, and if you want to create an application to address all the different aspects in your scenario, you have also to consider also this different kind of protocols and data models behind of that. And this is actually very, very expensive in IoT projects to find out and to understand what is this protocol, how to use the protocol, how the security looks like, and so on. And this is really the integration of this services that are provided is always a very in the context of high effort. Yeah. And this is where the Web of Things comes into the game. Yeah, as I showed on the beginning with this nice mashup and orchestration of service of web pages, there was the idea, well, it would be very cool if we can do something similar also in the IoT world. And that's the reason why the W3C also started this initiative Web of Things to provide a similar paradigm as we know from the web, and providing some building blocks like a common standardized device description language. I will explain to this in the next slide what this is. However, the idea is to simply provide the nice web technologies and the IT technology so that is used in the IT world also to the IoT world. And it should also work for all kind of protocols. It is a technology that is domain independent. It should work locally from the device via the edge up to the cloud. So it is applicable to each level on your IoT system. And what I really like also at the Web of Things group is we have a very good mixture of companies from the OT world and companies from the IT world. And so that's so you will see companies like Intel, Siemens, Hitachi, Oracle, and Microsoft there, which are involved in the standard and providing here the good proposals and technologies that the OT world and the IT world can work together each other. And what is also very nice, W3C is really, I would say, a royalty-free open standard, which really just providing these building blocks, which can be used in your ecosystem, in your specific environment, and can be used in a complementary way. And this is what I also like to show you in combination with OPC later. And to give you one of the basic aspects of Web of Things is what we called the thing description. I also love to compare this with a LinkedIn profile. So as you know, LinkedIn profile, you get always a nice introduction of a person, what's the name, how to contact them, how the CV look like. And here what we are introduced is to provide a LinkedIn profile for devices or for services to get information. What is the name of the service and what kind of information are provided there? So what kind of data and functionalities are provided there? And what is very important is also to understand what I have to do to get this kind of data. So here you see, for example, a snippet of a thing description that is based on a Modbus-based device. So you see here some data points like the voltage, phase 1, and some actions here, and you see also here some protocol-specific information like the Modbus register, or which offsets you have to do, and so on. So there are all this detail provided in the thing description. And the cool thing, as you can already see, is JSON-based. There's a JSON-based format. However, to be precise, it's a JSON-LD format. And JSON-LD is also a W3C standard, which enables you to specify your data in a JSON format, but also providing also this semantic or linked data concepts in there. So this is the LD extension, meaning there, so that you can rely on RDF approach. That's the reason why also this RDF sign is in the TD here, that you can also specify your content based on RDF concepts. Well, in the red on the right-hand side, you see the TD spec. I think it's a very straightforward spec. I think if you print it out, it has only 120, 30, 40 pages. I don't really more. It's very lightweight. It's, I think, a very lightweight standard to understand. However, it has a lot of potential, which I like to show you now in the following slides. And yeah, to bring this in context of the scenario that I showed before, what is here the expectation is, if you have now thing description of your endpoints to the ecosystem or of your devices, then it makes the application development much more easier, because you can simply rely on this common interface description, and you know, okay, there are some data points provided there, and you find also the details what I have to do to interact with this ecosystem, and that's it. Yeah. And if you rely on this, then you can also rely on some interpreter libraries, which simply reads thing description and then simplifies the interaction with the ecosystem independently, if you speak with OPC or some with Modbus or with BACnet or with OCPP in the e-mobility. Yeah. Okay. Now, since we are here in the OPC world, in OPC days, I would like now focus on the OPC, and I would like to zoom in here, and I would like to start to abstract the typical way how OPC typically used in manufacturing, for example. So typical, you have your shop floor devices, your sensor, your actuators, and then you have your controller or edge device, which provides all the sensor data or the functionality to this kind of device. And then you have there a mapping of the specific data points to OPC, yeah. And then from there, you can start to interact within the OPC ecosystem, yeah. So this is what is very high level, so where you can start then your OPC end-to-end interaction, or you have then your cloud communication, whatever. However, the question is, how does the data come into the OPC world? Yeah, how the sensor data, so Modbus or CIN or whatever that's there in the shop floor, how it comes there. And here's where Web of Things come into the game, where thing description can be used to simply provide the information, what data points are provided there, what functionality is provided there, what protocol is used, and how to use the protocol, so that I can make the data points mapping in my OPC mapping very easily. I will also show you this in one of the next slides, and which I also think would be a very benefit of OPC to use Web of Things when it comes to northbound communication. Yeah, so if you have an OPC server or a hub sub server, then it would be also nice to define specific data points that are displayed or coming or they are described in the thing description, so that you can use this exposed based thing description for non-OPC or scenarios, so that you say, okay, you want to integrate this mesh up scenario, or you want to orchestrate IoT application with other ecosystems, then it would be very cool if you can simply get the thing description so that the developer can simply understand quickly how to get a specific data point and where to get it and so on. Yeah, and yeah, in the next couple of few slides, I would like to dive in a little bit about the southbound and northbound. I like to start with southbound, and here I have to say we are already. Before we go into this, I forgot to mention regarding the southbound communicate or onboarding scenario, as I shown here, there's some good news. There will be a new working group at the OPC, which is called Web of Things Connectivity. And next week there will be the kickoff meeting. And I will also say something at the end about this, when it will happen exactly and so on. And about this northbound communication, there's also great news that we want to work on this in the next Web of Things charter. So currently we're planning the new charter, and it's starting in the next couple of weeks. And in the new charter, we also want to address this OPC binding, so that there is a formal way how information can be provided, which reflects our OPC server or subserver. Okay, to the sourcebound communication, to explain quickly how this works in principle. So let's assume we have a shop floor device like this energy meter that speaks Modbus. You can simply have this also as a thing description representation. Usually you have not that that kind of information in a machine interpretable way. Especially Modbus devices, you typically have to look up in manuals and so on to understand what data points are provided there and what register and offsets you have to do. But such information can be very easily also reflected in a thing description. So we have the standard for this to describe all the data points there. We have also specific side documents that describe the specific protocols, like the Modbus, so you find there all the metadata there to describe the information, what you have to do to get then the actual data point and so on. And what is very cool, and as already mentioned before, we are relying on JSON-ID, and we are able to integrate also existing context knowledge, existing definitions what already are there. And here it's very easy to integrate also companion standards and enrich thing description with OPC aspects. And here what we showcase that you can simply include this OPC energy management companion standard and say which data points are related to the companion standard, to the energy management, so that you can already have this direct information provided that it's helpful for then the OPC representation in your OPC ecosystem. And if you have then such kind of information and you want to apply, for example, a specific IoT stack, here we are showcasing example of the Azure IoT, and this is what we also showcased on the Hanover Fair, is that you simplify the integration of the data to the cloud. So usually you have to describe here the devices on the described devices, then you do the protocol translation like the Modbus to OPC, and then you have to represent all the data points to the UA representation and so on. And then on the top, you have then really the data point which you would like to really work on, and you create your application. And instead of doing all this manual work in between, you can simply use the thing description as a supporting information provider that that you don't need to manual enter anymore all this device information. You can simple import information from the thing description, and you can also directly create your OPC data model, because you can also rely on the OPC information that already provided in the thing description. Yeah? And this is, I would say, a very cool stuff. If this is really working in that way, because typical here down, there's always the most effort and time and cost invested to bring the action data which you would like to see on your application is really always the most aspect on the very lower level here, and the thing description can really shorten this effort here and reduce the effort here and simplify this. Erich Barnstedt from Microsoft already provided for this scenario open source information. Here's also the link provided where you can also play around with it, and so that you can also see how this would look like in implementation. I would like also quickly explain how the northbound aspects would look like with the thing description. So let's assume now we have here our OPC server running, which reflects a pump, and you want to provide a data point of this pump, namely this pump speed here, and you can simply define such kind of thing description as well. So you can provide information where I can find this OPC server. So we use this demo server from Stair5 here in that case. Then you can also explain what security modes are provided here. So we are going no security in that kind of way, but it would be also possible to have also other security modes provided here. And yeah, and then you can start to provide your A variables, all the details. And then you, of course, can also provide the address of the UA variable, which typically is the node ID, and so on. Yeah. So this is an approach which already works very well. So there's a first draft and first idea how this can look like. And as already mentioned, we want to formalize more, and we have to consider more aspects like what happens if the node ID is changing. Then we most likely have to work with the extended node ID and so on. So there are still open questions here, but to give just the idea how this can look like and which direction looks like is simply shown here. And well, before I conclude my talk, I would like to show a very small scenario how easy it is actually based on Web of Things to make this orchestrated mesh up applications. Yeah, let's assume we have now this pump here which speaks OPC, and we always want to check every 5 seconds how is the pump speed looks like. And if the pump speed is over 200, then I have a counter here which speaks HTTP. And if the speed is over 200, then I want to increase the counter, and otherwise I want to decrease the counter. And here I like to show a snippet of a Node.js implementation. There's also a Web of Things library existing for this, which is called ThingWeb. And yeah, to have this small scenario here, it's really easy to create this application. So what you simply have to do is you have to provide the location of the thing description so that the library understands what kind of opportunity to have with this thing here and what kind of data points are provided there. So in this case, we have here this for the OPC for the pump, and then we have also the service of the HTTP counter here. There is also a thing description provided, and having this, that's actually everything what you need to do here. You can then start to concentrate on your business logic. Yeah, so you simply read now your pump speed, you're getting the value, and then in here you simple evaluate how fast is the pump currently, and if it's higher than 200, then you're going to increment the counter, and otherwise you're going to decrement. And this is a few lines of code where you combine OPC UA and HTTP, different protocols, in a very easy manner to each other. Yeah? And I think it's just as very, I know it's a very simple use case, but what you not see here, for example, is all this protocol stuff in here, like, yeah, what node ID I have to use, what's the namespace, what content type I have to use, which HTTP method I have to call, how the resource look like, what you typically have in your source code or your source codes can be now avoided by relying on Web of Things, and you can really start to concentrate on your actually, application and business logic, and so on. Well, there is much more possible with Web of Things, like validation, rapid app development. So as I already showcased before the slide, you can do easily UI generation based on thing description. And as I mentioned, based on the RDF approach, that is the thing description, you can also rely on the RDF stores and all the query mechanism in the background. So this is also possible. And also it is a very, very great baseline for doing AI applications. And here again, I would recommend that you join Tomo's talk from Erich Barnstedt. He will then give more insight how ChatGPT and thing description, Web of Things can be combined to simplify also the asset onboarding to OPC UA here. Well, at the end, I would like to quickly give you some inputs if you are interested in now Web of Things and you want to play around with it. So I can recommend to have a look on the open source implementation. There's this Eclipse Node.wat, which has already a first version of OPC UA binding. So this is a first approach how this look like, and it's relied on the well-known Node OPC UA stack from Star5. If you like some supports to edit your first thing description, there's also open source tool, editor where you can do this. And as already mentioned, there's also this Edge translator from Microsoft that enables to bring thing description to OPC UA. And yeah, there was also an OPC UA podcast, which I was invited and gave also a talk about this, what we have presented at the HMI, namely the OPC UA, Web of Things, and ChatGPT 3 team. So if you have not heard that, you are really welcome to have listen to it. And of course, there's also a Web of Things webpage where you find all the details about the specifications. So there's many more specifications. Web thing description is just one aspect of this. And then you find also a nice overview about all the Web of Things tools that are currently available and possible. And there are also some explainer videos and so on. Well, I like to conclude. So as I showcased in the presentation, Web of Things is a very cool thing which can complement OPC UA, and supports the asset onboarding into OPC UA, and also helps to easy integrate OPC UA system for cross-X application. And here I would like to point out then that next week is the kickoff meeting for the Web of Things Connectivity Working Group. So that's happened on June 27. Here you see your time zones where the web meeting take place. And well, and definitely you're also welcome to join the Web of Things next charter. So it's not started yet. It's starting in the next couple of weeks. And typical when a new charter starts, it's always a good time to be involved from the very beginning. So that you're also involved in all this discussion, which we're planning and to specify in the next version of Web of Things. And as I already mentioned, one of the tasks we would like to challenge is the OPC UA binding and so on. Well, and this is the last aspect I would like to show here. I think I showcased here that both technologies works perfectly to each other. They benefit to each other. And maybe not many people know there is already a liaison existing or memorandum of understanding existing, which I have linked here. So if you would like to have a reading on this, then you can also click on this link here. Well, then I like to conclude or close my session. And yeah, I will be there for the Q&A, and I will also check the chat if I already can answer some question here.